The fundamentals of stall recovery. During the practice of intentional stalls, the real objective is not to learn how to stall an airplane, but to learn how to recognize an approaching stall and take prompt corrective action. Though the recovery actions must be taken in a coordinated manner, they are broken down into 3 actions here for explanation purposes. First, at the indication of a stall, the pitch attitude and angle of attack must be decreased positively and immediately. Since the basic cause of a stall is always an excessive angle of attack, the cause must first be eliminated by releasing the back elevator pressure that was necessary to attain that angle of attack, or by moving the elevator control forward. This lowers the nose and returns the wing to an effective angle of attack. The amount of elevator control pressure or movement used depends on the design of the airplane, the severity of the stall, and the proximity of the ground. In some airplanes, a moderate movement of the elevator control, perhaps slightly forward of the neutral, is enough, while in others, a forcible push to the pull forward position may be required. An excessive negative load on the wings caused by excessive forward movement of the elevator may impede rather than hasten the stall recovery. The object is to reduce the angle of attack, but only enough to allow the wing to regain lift. Second, the maximum allowable power should be applied to increase the airplane's airspeed and assist in reducing the wing's angle of attack. The throttle should promptly but smoothly advance to the maximum allowable power. The flight instructor should emphasize, however, the power is not essential for a safe stall recovery if sufficient altitude is available. Reducing the angle of attack is the only way to recover from a stall regardless of the amount of power used. Although stall recoveries should be practiced without as well as with the use of power, in most actual stalls, the application of more power, if available, is an integral part of the stall recovery. Usually, the greater the power applied, the less the loss of altitude. Maximum allowable power applied at the instant of a stall will usually not cause overspeeding of an engine equipped with a fixed pitch propeller due to the heavy air load imposed on the propeller at slow airspeeds. However, it will be necessary to reduce the power as airspeed is gained after the stall recovery, so the airspeed will not become excessive. When performing intentional stalls, the tachometer indication should never be allowed to exceed the red line maximum allowable RPM marked on the instrument. Third, straight and level flight should be regained with coordinated use of all controls. Practice in both power on and power off stalls is important because it simulates stall conditions that could occur during normal flight maneuvers. For example, the power on stalls are practiced to show what could happen if the airplane were climbing at an excessively nose-high altitude immediately after takeoff or during a climbing turn. The power off turning stalls are practiced to show what could happen if the controls are improperly used during a turn from the base leg to the final approach. The power off straight ahead stall simulates the attitude and flight characteristics of a particular airplane during the final approach and landing. Usually, the first few practices should include only approaches to stalls, with recovery initiated as soon as the first buffeting or partial loss of control is noted. In this way, the pilot can become familiar with the indications of an approaching stall without actually stalling the airplane. Once the pilot becomes comfortable with this procedure, the airplane should be slowed in such a manner that it stalls in as near a level pitch attitude as possible. The student pilot must not be allowed to form the impression that in all circumstances a high-pitched attitude is necessary to exceed the critical angle of attack, or that in all circumstances a level or near level pitch attitude is indicative, I think indicative was the word I was supposed to use before, of a low angle of attack. Recovery should be practiced first without the addition of power by merely relieving enough back elevator pressure that the stall is broken and the airplane assumes a normal glide attitude. The instructor should also introduce the student to a secondary stall at this point. Stall recoveries should then be practiced with the addition of power to determine how effective power will be in executing a safe recovery and minimum altitude loss. Stall incidents actually result from an inadvertent stall at a low altitude in which a recovery was not accomplished prior to contact with the surface. As a preventative measure, stalls should be practiced at an altitude which will allow recovery no lower than 1,500 feet above ground level. To recover with a minimum loss of altitude requires a reduction in the angle of attack, lowering the airplane's pitch attitude, application of power, and termination of the descent without entering another secondary stall.